Okay, hello and welcome back to the Land Rover Toolbox videos. And if you remember in the last video we had a little bit of an issue with this welder because it was blowing fuses at about 130 amps, which when I set it down to about 110, I think that was 100 to 110, that was fine. But any higher than that and it just took fuses out in the 13 amp plug that's you can see on the wall there. This 16 amp, okay, that will weld at 16 amp and possibly higher, but we do have some issues in the circuit breaker box down there. Underneath the box of rivets there are 16 amp and 32 amp breakers, circuit breakers in there, and we're going to have a look at the electrical side of welders. And I must admit I don't know very much about it, but we have an electrician coming in to put us a 32 amp plug socket in, so I'll get him to explain it to me and then I will come back and explain it to you. Anywho, this is the SIP Merlin 210 amp welder. I bought it second hand. It's been into the Ukraine and it's been rigged so it doesn't blow fuses. It does go into circuit breaker of 16 amp. Now this is only AC positive. You can see that it tells you there's not a plus and a minus on it. It's just clamp and electrode cables, right? So this one here, very rugged, and it basically you just adjust the voltage, and on the top, show you just here, you have a bar just like an old-fashioned radio would have had, and somewhere there you can see that it will tell me that in a certain area it will weld a 3.2 millimeter electrodes. So if I just go onto the top there, you might be able to see the white bar in here and a 3.2 millimeter zone, so we're okay there. And I had to crank it up just a little bit more to get the voltage out of it because the cables on here are quite long. Just a funny little story with this welder. When I was using it in the Ukraine, it was knocking out the neighbours' fridges because over there the electricity is just not stabilised at all. So if you ever go there, just watch out for that. Not the best welder to have. It's very simple. It only has AC, unlike the Power Weld one where you can weld in all sorts of settings. This is old-fashioned electrode welding, and to be honest with you, if you're just doing simple jobs on fairly thick metal for domestic purposes, it's okay. I'll just show you some of the tools I have, which is vital for stick welding, and that one of those is having a slag hammer, and this is to knock the slag off. People say that the slag should just drop off, but there are times when you need to chip it off, and the hammer is self-evident how to use it. Basically, yeah, crack it off and look, you have a weld underneath. That's the thing with this welding, it is messy. Now I have some magnetic clamps here which you can see, these are at 90 degrees, which are brilliant. You can drop some weldings and do some tacks. The equipment I've got here with the clamps you can get from forby.co.uk or from Arkwright as well. Take a look, and you'll need some for clamping work down later on. You will need angle grinder or angle grinders for welding preparation, and this little Milwaukee, it's an 800 watt one. I'd say that it is it's okay, it's not underpowered. So I have a large selection of grinding and cutting discs. These ones are slitting discs. You can either get them for aluminium or for steel, and they are quite flimsy. Now I'll just show you here, here's the plug, and I have my key when I'm undoing discs, and this is vital. You don't want to switch it on when you're undoing one. Older grinders, they might not accommodate for slitting discs because they're only 1 millimeter thick, but what we have here, we have the bottom plate and we can fit our slitting disc on. Okay, now there is a boss there which it sits in. Now you have on the top part here, you have either recessed or you have a bossed one or raised boss, and you need to have it so the raised boss is on the outside, so you're clamping the disc fully. If it doesn't tighten up even by finger tight, then you have a problem and don't use the disc. If you put it round this way, then you'll find that the disc will spin anyway. This is not the right way to fit it. You can see that that's loose, so that is a no-no. So basically in the UK we have two types of dimensions, and that'll be 4.5 inch, which is 115 mil, or we have a well, I don't actually know what that is in mil, that's a 4-inch. And that's 100, isn't it? Yeah. So basically, you do not use 400 on a 115 millimeter disc grinder, okay? Because they're not compatible at all. They don't even fit. So just make sure you know your equipment. Now, again, the slitting discs here, you buy them in packs of, well, however you want. They do not last long, but they cut very quickly. Now, the problem with them is because they're quite thin, they can get damaged. Some people will square these up again or round them off. I don't. I chuck them away if they get damaged and always replace with a new one. I do keep a big stock of them because I go through them like nobody's business. Grinding discs, okay, there's no big issue there. Just remember that you want for the size of your grinder, which in our case is 115 millimeters. Now, as I was saying before, how you fit the boss is face downwards like that. That's what that one is for. So that fits the grinding disc in there quite easily, okay? Now I usually nip it up finger tight, then just a tweak with the key so the disc doesn't come undone. Basically, the grinder is for grinding steel and not aluminium. It clogs up the grinding disc and can explode. I just want to show you these little discs here. These are for air cutters. Surprisingly, these discs last a long time and you can get in small places. Now, these are flat wheels, which I do like. These clean off rust without taking off metal. Again, you can see the dimension here, and somewhere, I'll just see if I can find it. There should be a grit rating. So you can see down there, that's a 60 grit, okay. So that's a fast 60 grit. I do have a collection of them. They are handy, and as I say, they don't take off much metal, and they don't produce that much spark either, as you can see here. But it's good for cleaning off mill scale from the metal, without leaving horrendous grinder marks all over it. Okay, that's enough for equipment and tools for now. So let's get back to welding. Now, the best thing to do is to run beads down a plate and get your weld consistent. And you'll find possibly that you won't go in a straight line. And this is actually a bad habit of mine if I have no guide. I've started to run beads together and they come in right, but I found myself a guide and marked it. It's the same as welding two plates together. You can actually weld it quite easily because you have a groove to work to. So if you are going to pad beads, as it were, or put beads down on a plate, which you should do for flat welding practice, then make sure you have some sort of guide instead of going all over the place. Also, make sure that the slag is thoroughly cleaned off your workpiece, off the weld. Use a wire brush before you lay another bead next to it. This flat position welding is the best when you're first starting to use a stick welder, and I've started this 3 times. I'll just take the slag off here, and well, actually it doesn't look too good, does it, at the moment? It looks like there's gaps, but once it's clean, you'll see that the start and, or should I say stop and then start, is fairly consistent, so it looks like one complete weld. On the other side, you can see I've tacked it, and you can see where the heat has gone to, but there's not full penetration through this weld. It's not important, and you'll see here the heat has also bent the 2 plates out slightly. The key to good successful welding is to practice, and then practice and practice some more. Once you start to understand where your arc should be, and you notice what's happening at the end of your welding rod, you'll then understand it can be controlled. Now, what I've done here is I've run beads and then I've stopped, and you can see here, I'll just show you what you do to start again is run back on it, and then start welding again and just finish off a bead. You could cover the whole plate in these beads, but get them as close as together as possible. The electrode is at 3.25 millimeters. I'm running at 130 amps, and the steel plate is 5 millimeters thick. Then this was bought from local engineers. It's good thickness to practice on. Now, the clamps here, they come in really handy because later on we'll be doing vertical down and vertical up welding, which is actually quite difficult. Once you understand what's going on and you know where the weld pool is, it becomes easier. Now what I've done here, I just tacked on a plate onto the chassis, and I'm going to quickly show you another technique which with horizontal welding I'm actually pushing rather than dragging the electrode. And you can't see it here, but if you look in the weld cam you can see I'm actually pushing this along, okay, rather than dragging it. And this is another technique you can use and practice with your electrode for control. This is not brilliant, but what you can see is that I'm actually going forward and then going back on itself, but keeping control of the weld pool on this one. Phillip welding, well, you get your rod at 45 degrees in there and then bend it over just slightly and then weld along the gap. Now this is not as easy as it seems. You also got edge welding, which isn't that easy to do, and of course you got fillet, which could be horizontal or vertical welding. These also are slightly more advanced welding techniques and you're going to have to learn them. Now with the fillet weld, obviously it's 2 plates at 90 degrees. So basically you could lay one of the plates flat and then weld across like this. It's good practice, and the cheating way is to lay it so you're actually doing a flat weld into the V itself like so, which is also good practice. But of course things like chassis will not let you move them about too much, will they? The other weld we have to consider is a lap joint. Now that's 2 pieces of metal laid like this, and you'll probably have to do this somewhere on the chassis. Okay, that could be vertical or overhead, for instance. Basically you're welding these 2 plates together along like so, which we're going to have to cover all of these later before we get on and weld our chassis up. The other weld, of course, I've shown you but not shown you how to prepare it, is the butt weld, which is just butting 2 pieces of metal together. And there's plenty of different ways of doing this, and of course different positions, flat, horizontal and then verticals, and we're going to have to get all of this nailed before we go ahead and get a good job done on our chassis, won't we?